So a student determines the concentration of dilute sulfuric acid by a titration of sodium hydroxide is there. 25 cm cube of 0.2. Sodium hydroxide was transferred into a conical flask and 3 drops of methyl orange is added. What will the color of methyl orange in alkaline? Alkaline solution. Methyl orange. Red in alkaline. Then yes, yellow. A burette was filled with a sulfuric acid, so H2SO4 is there. So H2SO4, we add H2SO4 until a methyl orange, the indicator show a color change. What will the final color of the solution? It should be either neutral or acidic, as you can see here. So originally it is yellow, but why it is written orange there? Because it is in a neutral solution. Like in a sodium hydroxide, it is yellow in color. Alkaline solution actually, this this alkaline solution, it is yellow in color. But when we add sulfuric acid, all the sodium hydroxide will be used up and indicators show a color change. Neutral solution, then because it is neutral, that's why it is written orange. So the final color will be orange. Okay? A burette, because acid is added here. So initially alkaline and then acid. Now the acid in a burette is added, indicators show a color change, the volume of acid recorded, and the process is known as titration. The titration is repeated several times. How many times we should repeat titration? How we'll know like enough times we have done this titration? Yes, until the two results are concordant or two results are closer within a 0.2, like either 0.2 more or 0.2 less. The results are concordant till 0.2 cm cube. That's right. We should repeat. So name a piece of apparatus which is used to exactly to 25.0 cm cube. Which apparatus? Exactly. Burette, but if you want to measure a fixed volume, a single fixed volume, in that case, a pipette is accurate one. Burette is when we want to measure the accurate volume from 0.1 to 50 cm cube. We can use burette, but the pipette is more accurate because a single fixed volume is by pipette, which is 25. State the color change. So originally it is yellow and then it will turn orange. State how student decide that suitable number of results have been obtained. That's the same thing like how we decide until the two results are close or are concordant to 0.2 centimeter cube. Like two results repeated or within the range of 0.2. The next one is 20 cm cube reacted with 25 and 0.2. Calculate the number of moles of sodium hydroxide, then determine the number of moles of sulfuric acid, and then find the concentration. How many moles of sodium hydroxide? Moles is concentration into volume. So concentration is 0.2 and the volume is 25, which should always be in decimeter cube, so divide by 1000. So 25 divided by 1000 into 0.2, what's the answer? So 0.025 multiplied by 0.2. 5 exponent minus 3, or we can also say 0.005. So these are the moles. Now we need the moles of sulfuric acid. So from moles of sodium hydroxide, we'll get the moles of sulfuric acid. So we'll take a ratio between sulfuric acid and sodium hydroxide, which is 1:2. So if we have 0.005, then how many moles will be there? X. We cross multiply. So when we cross multiply, so this will be half of it. So 0.005 divided by 2, 0.0025. Then calculate the concentration of sulfuric acid. What will the concentration of a sulfuric acid? We have the moles and we have the volume, which is 20. Sorry, the original volume was 25. Yeah. This was the volume and concentration. Now this is volume is 20. So we need the concentration. Concentration is moles divided by the concentration is moles divided by volume. So 0.0025 and the volume is 20 divided by 1000, so 0.02. 0.125, so the concentration will be 0.125 moles per decimeter cube. So whenever you solve a moles question, first if you see, first you use a formula, then you use a ratio, and then you will use again a formula. So it's a sequence is there. It's not like all questions solve in the same manner, but always a formula, ratio, formula sequence is there in the moles question, like most of the time. Page 5, discussion is about the salts. Salts that are insoluble in water are made by precipitation. Lead to iodide is an insoluble salt. All nitrates are soluble and all sodium salts are soluble. We are provided with a solid. We have two solids. We have lead nitrate solid and we have a solid sodium iodide. Describe how you would make a pure sample of lead to iodide. In your answer should include the practical details and the chemical equation for the precipitation. First, practical details. First, what we do, we will transfer them into a test, because this is a test tube reaction, it's not a large scale. So we can take two different test tubes and transfer solid lead nitrate and solid sodium iodide by the help of spatula into the two different test tubes. Sodium iodide and lead nitrate are transferred into two different test tubes. They will be white solid. Then what we do, we add a distilled water or deionized water. We add a distilled water or deionized water until all of the solid, will shake the mixture, like shake the test tube so that the solid will dissolve. In a test tube, you cannot say stir. Why you cannot say stir? Because so small to place a stirrer, or that's why for a test tube you must mention a shake the test tube rather than stir. So we shake the test tube so the solid will dissolve. When the solid will dissolve, what we'll do, we can do one thing, like we can transfer them into a beaker and add the two solutions together. When we add the two solutions, what will happen? A solid will form. What will be this solid? This will be lead to iodide. And if a lead to iodide is formed, how we can remove this lead to iodide, the insoluble solid? Filtration. So we'll filter and then we will wash. And what is the equation? So we will add the two solids, then we will dissolve, then we will filter, and we will wash. I'm writing the points in short, but you're supposed to explain practical detail like how it is done. And the equation is, when lead to nitrate and sodium iodide, we need only the symbolic equation. So it will form lead to iodide PbI2 plus sodium nitrate. The equation must be balanced. So we have two nitrate, so we put 2 here, and iodine is also 2, so the equation is balanced. And whenever you want to balance equation, you, for normal equations, you will start with oxygen followed by hydrogen and then at the last any other element. So how many oxygen are there? 3 multiplied by 2, 6. So how many oxygen we need? 6. So 3 are already there, so I will put 2, so it makes 6 oxygen. And here then we have, there is no hydrogen, so any other element, iodine 2. So if we put 2, iodine is also 2 and sodium is also balanced. So this equation is balanced in terms of all the elements which are given. A chemical equation for the precipitation reaction, so you can write ionic equation here as well, because the precipitation is they did not specify you the chemical equation, the marking scheme is there. So here. So both are acceptable if you mention a full equation or ionic If you can see here, full equation or ionic equation, both are acceptable, as ionic equation is also a chemical equation. But usually when they say ionic equation, they will specify like write ionic equation. But they accept because that is also the equation. So this was page 5.